So the first question right out of the freaking gate, this was not a repeat question, but it was a question similar to the June 2017 Regents exam. Again, they're testing your knowledge on Cavalier's principle without even saying Cavalier's principle in the question. Let's talk about it. Sue believes that two cylinders shown in the diagram below have equal volumes. Is Sue correct? Explain why. So the first thing that should pop into your head is that one of these is a cylinder, one of these is an oblique cylinder. An oblique means that it's slanted in some way, shape, or form. So she's saying these definitely take up the same amount of space. Don't forget that volume means the amount of space it takes up. Okay? Does it? Well, we got to figure that out. So, to prove Cavalier's principle, you need to do one of two things. The first thing that you need to do is prove that the bases of the prisms are equal to each other. Then you need to prove that the heights are equal to each other. Well, let's do this now. Let's find the area of this circle down here, because this is a circle. So the area of the circle in, let's call this prism A and let's call this prism B. The area of circle A is equal to pi r squared. Okay, that's the area of a circle, pi r squared. The area of circle A is equal to pi. The radius is 5, and you square it. The area is 25 pi. I'm not going to type that into my calculator. I'm just going to leave it as is. The area is 25 pi. Okay? For prism B, on the other hand, let's take a look. The area of circle B is equal to pi r squared. The area of circle B is equal to pi. Now, the diameter is 10. The radius is 5. So we get 5 squared. This is, again, 25 pi. Okay, so far we're in the running that these two volumes are equal. So, that the areas are equal. Are the heights equal? 11.5, 11.5. Don't be fooled by the 12. Don't be fooled. Don't be fooled. It is the vertical height that they're talking about, not the slant height, the vertical height. And they are. They're equal. We're happy because the volumes are equal according to Cavalier's principle. So, your explanation in words is this. Due to Cavalier's principle, if two prisms are the same height and have the same cross-sectional area at every level, then the volumes are equal. So yes, Sue is correct. And that's it. That's how you answer that question. We explained what Cavalier's principle was. We gave a yes that Sue is correct. We got the full 2 points. Run with it. We're good to go. Number 26. This is the simplest part 2, in my opinion, out of them all. In the diagram of rhombus PQRS shown, the diagonals PR and QS intersect at point T. PR, the length of PR. All right, so the diagonal PR, let me get a highlighter here. The diagonal length of PR is 16. And the diagonal length of QS, well, that has a length of 30. Okay? Now, it's saying here, determine and state the perimeter of PQRS. So what you need to remember about a rhombus is that they form right angles in the middle, or the diagonals form right angles because they're perpendicular to each other. So what does that tell you? It tells me that these are 4 right triangles here. 1, 2, 3. There's 4 right triangles in this diagram. So, and in addition, the diagonals bisect each other. So this is congruent to this, and this is congruent to this. So if this whole length is 16, that means that this is 8 and 8. And if this whole length is 30, that means that this is 15 and 15. Well, what we could do from here, which is pretty sweet, is we could apply Pythagorean's theorem to one of the triangles and get the length of the hypotenuse, then just multiply that number by 4. Let me explain why. The four sides of a rhombus are congruent to each other. This is a right triangle. If we're given 2 legs of a right triangle, we could solve for the hypotenuse by using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So I'm just going to take the 2 legs, which is 8 and 15. I'm going to square them both, and that equals c squared. Okay? So we get 64 plus 225 equals c squared. 64 plus 225 is 289 equals c squared. Take the square root of both sides. We get that c is equal to the length of 17. So this one side of the rhombus is equal to 17. Since a rhombus, they tell us that it's a rhombus. Since the rhombus has 4 congruent sides, we just take 17 and multiply it by the number 4. Your perimeter is 68. This, ladies and gentlemen, is your answer. The perimeter of the rhombus is 68. Okay, that's how you do that question. Not too bad. 27. All right, this transformation looks a little wacko. Quadrilateral math and its image, quadrilateral M double prime A double prime T double prime H double prime, are graphed on the set of axes below. Describe a sequence, here we go again, sequence of transformations, meaning multiple transformations that would map quadrilateral math onto quadrilateral M double prime A double prime T double prime H double prime. Let's take a look. Now, here's the thing, people. There are many answers for this question. I'm going to give you my answer, and if you want to take it, that's fine. If you want to confirm that your answer is correct, you could either email me or you could ask your teacher or anyone else that's good at math. So let's take a look here. We know for a fact that it's a rotation about something, but we got to be specific. A rotation about what point? The point, it looks maybe like the point negative 0.5, 0.5. That could work. Okay. What I personally said is I kind of went the easy way. I said rotate it 180 degrees, centered at point H, meaning spin it around to translate it on in this vicinity, and then translate it to the left one, then up one. Okay? So my answer was a rotation of 180 degrees, centered at point H, followed by a translation to the left one by 1 unit and up by 1 unit, which by the notation it's a translation of negative 1 comma 1, will map math onto M double prime A double prime T double prime H double prime. And that, ladies and gentlemen, is how you answer that question. Again, there are so many other answers that you can use. If you want to just confirm, just ask me or your teacher. All right, moving on to question number 28. Oh, this is a construction question. Using a compass and straight edge, construct a regular hexagon inscribed in circle O. Leave all construction marks. Okay, so the first thing that I want to establish or to understand is that a regular hexagon means that all 6 sides, and there's 6 sides in a hexagon, all 6 sides are congruent. Okay? So I'm going to take my ruler or my straight edge, and I'm going to construct a radius from O to this endpoint. I'm going to call that endpoint point A. So now what your goal is to take your compass and place it on A, spin it around in intervals, draw your hexagon, and you're done. By the way, if you don't like what I'm doing on the computer, I have a hands-on construction immediately following this. So if you want to fast forward that, if you don't like it this way, that's perfectly fine with me. Or if you want to watch both, that's fine too. So here we go. What we're going to do is we're going to place our compass point on the radius or sorry, the center of the circle, which is O, measure the length of the radius. We need that length. Now what I'm going to do is I'm going to place my compass point right on A, directly on A, and I'm going to construct my first arc. Then the next thing to do is place your compass point on the new intersection point, which is here, and repeat the process, like so. Do it again. And keep on going until you reach back to point A. Now, here's the thing. You should get back right onto point A. The chances of that happening are slim to none just because the human hand is so shaky. So let me just tell you that it's normal if the compass goes a little bit further or less than what it's supposed to. That's okay as long as you get the right idea. And see, I have a feeling that it's going to go over. And it is. It's going to go over. You could... That's an acceptable error. Honestly, though, if you get that, I would honestly just fix it. And I know how to fix it just because I've been doing this for a while. But I know how to fix my arc measurements. So I could do it... Oops. I could do it just like this. So I have the capabilities of just moving my little tick marks. You need to redo the thing. So I know for a fact that this is correct. All 6 sides are congruent. Draw your things. 1, 2, 3, 4, 5, 6. Just use it with the straight edge, and you have your regular hexagon. And that's how you do the construction. For the next thing, you'll see more hands-on construction, and we'll go on to the next question after that. All right, so here's question number 28 on the August 2017 administration of the geometry regions. This is just a hands-on construction. Here we go. Number 28 says, using a compass and straight edge, construct a regular hexagon inscribed in circle O, leave all construction marks. So it's just the same procedure as before. In order to construct a regular hexagon, meaning that all 6 sides are congruent, the first thing that we need to do is indicate a point on our circle, and I'm going to call this one way over here. I'm going to call this point A. And that's just calculated by drawing any radius from point O to the outside of the circle. So that's just our radius to work with. Now what we need to do is take your compass, any type of compass would do. Take your compass, place it on point O, and measure the length of the radius. Just like so. Now once we get the length of the radius, you're then going to take your compass point and you're going to place it right on A, and you're going to measure like so. Okay? So once we measure this, now we just continue the process. Place your compass point on the new intersection point right here, and we're just going to continue the process all the way around. Now it should be lined up perfectly on your sheet of paper, meaning that the point of the compass should line up perfectly in the center of the intersection point, or else you will be off by a few centimeters. All right, so continue the process all the way around, and you should come right back to point A. And in this case, I am lucky enough to come very, very close to point A. So now all we need to do is just take a straight edge and take our pen and just draw or connect the dots of the intersection points. So from here, you could just draw all the way around, like so. Now, after you draw those lines, it would be beneficial just to label all of your points, but it's really not necessary. So if you would like, you could label this as A, B, C, D, E, and F if you want to be very specific. And that is how you do that question.
This is August 2017 Math Geometry Regents question number 29. It says the coordinates of endpoints, this symbol means segment AB are A. It occurs at 2, 3. So right away I'm going to put an X above the 2, a Y above the 3, because I'm actually going to, although it says the use of this axis below is optional, I'm going to use it. I like a very visual learner. So I'm going to go over 2 units along the x-axis, and then I'm going to go up 1, 2, positive 3 units on the y-axis and call that A. It says B is located at 5, negative 1. So once again, I'm going to put X above the 5, which tells me to go 1, 2, 3, 4, 5 units on the X-axis, but negative 1 on the Y-axis. So that's point B. And it says that this is a segment. So I'm going to use a straight edge, and I'm actually going to draw that. Here we go. It says to determine the length of segment A prime B prime, the image of segment AB after a dilation of a half centered at the origin. All right, so there's a couple of different ways you can do this. So one way is to start with finding the length of the original segment, and then the dilation means that the figure is going to get bigger, or in this case, because it's multiplied by a number less than 1, it's going to get smaller. So if I form a right triangle here, I can actually say this is 1, 2, 3, 4 units down, 1, 2, 3 units across, and I can use this right triangle, and now I can use the Pythagorean theorem. So using the Pythagorean theorem, I can say that a squared plus b squared equals c squared, where c is always the side across from the right angle, which means that's going to be the length of segment AB. So we're going to use the numbers 4 squared plus 3 squared equals c squared. 4 times 4 is 16. 3 times 3 is 9. That's equal to c squared. 16 plus 9 is 25. And the opposite of squaring is square rooting. So the length, I'm going to change c to segment AB. The length of segment AB is 5, which means the length of segment A prime B prime is going to be half of that. So 5 divided by 2, or you could have said 5 times a half. Either way, you're going to get segment A prime B prime to be 2.5. Now that's one way of doing it. You could have said if we take point A at 2, 3 and we dilate it by a half, that means we're going to multiply each of these numbers by a half. 2 times half of 2 gives us A prime, that would be 1. Half of 3 is going to be 1.5. Then we're going to take 0.5 negative 1. We're going to also multiply both numbers by a half. And then B prime would end up at half of 5 is 2.5. And half of negative 1 is negative a half. So what we can do this time is we can plot these points. So point A is at over 1, up 1.5. That's going to be A prime. And B prime is going to be at 1, 2.5, and then down a half. Oh, this is going to overlap this just a tiny bit. So let me use this straight edge, and then I'll use a highlighter. So I have this straight edge here, and then I'm going to use this highlighter here. Here we go. So this is the segment we're now actually finding the length of. So if we do the same thing and form a right triangle, we're going to go down, that's a half, that's 1.5, and down another half. So the length from here to here is going to be 1.5, and the length from A prime over to B prime this way is going to be a full Wait, let's go back here. I'm sorry about that. This is a half. This is 1.5 and another half. So that's going to be 2. Sorry about that. So the length from A prime down to the right angle will be 2. And the length from the right angle over to B prime will be a full box, 1 and then a half. So this will be 1.5. So if we go back and we do the same process, which is the Pythagorean theorem, A is going to be 2 squared plus the distance from the right angle over to B prime is going to be 1.5 squared. That'll be equal to c squared. Well, 2 times 2 is 4, and 1.5 times 1.5 is 2.25. That's equal to c squared. When we add 2.25 plus 4, that gives us 6.25 equals c squared, and the opposite of squaring is square rooting. And the square root of 6.25 is actually 2.5, and that's going to be the length of A prime B prime. And I'll just show you that math right here on the calculator. It is the square root of 6.25, and there's where that 2.5 comes from. So you have a couple of different ways to do this problem. This is two of them. All you have to do is make sure that you show the appropriate work for the information that you're trying to show, and you'll receive absolute full credit.
Stuff. Number 30. In the diagram below of triangle ABC and triangle XYZ, a sequence of rigid motions maps angle A onto angle X, angle C onto angle Z, and AC onto XZ. Determine and state whether line segment BC is congruent to line segment YZ. Explain why. Okay. Do you think that those two line segments are congruent? And if you're saying yes, you are absolutely correct. But you need to get the right reasoning. These two triangles, excluding this, because they asked us that information, excluding this, look at what we have here. We have an angle, a side, and an angle. Angle, side, angle. These two triangles are congruent by angle, side, angle. So if we have triangles that are congruent already, we could prove anything else to be congruent by CPCTC, which stands for corresponding parts of congruent triangles are congruent. So determine state whether that is congruent. Explain why. Yes, BC is congruent to YZ. Triangle ABC is congruent to triangle XYZ by the angle, side, angle, triangle congruency postulate. You don't have to say that, but you could just say that they're congruent and leave it at that. But you need to say that they're congruent by angle, side, angle. I'm just putting those words afterwards. Okay? Then we could say that BC is congruent to YZ by CPCTC, which again stands for, if you don't know, corresponding parts of congruent triangles are congruent. And that's how you prove that. Pretty basic question. I didn't think it was that bad. Could have been worse, but that is all you had to do for that question. Okay, this was a rare question just because it was a part 2. It's usually a multiple choice. So you actually have to know what you were doing and show your work. Number 31 says, determine and state the coordinates of the center and the length of the radius of a circle whose equation is x squared plus y squared minus 6y equals 56 minus 8y. Oh, we got some problems here, folks. We need to take this form. This is called general form or standard form. It's general or standard form of a circle. We want this in center radius form. And if you don't know the center radius form of a circle, it's this. X minus h squared plus y minus k squared equals r squared. Well, why would we want that? Because we could actually easily determine the center and the radius in center radius form, hence the name. So what we're going to do is we're going to perform an operation or a method called completing the square. You learn this in Algebra 1. And I told you in Algebra 1, if you watch those videos, if you were watching my Algebra 1 videos when you were in Algebra 1, now you're in geometry, completing the square comes back to bite you in the butt. And make sure that you remember completing the square for next year in Algebra 2, because you're going to see it again on the Regents exam. So completing the square. I always tell students, keep letters on one side, numbers on other. So what we got to do is we got to take that negative 8y, which is bugging me, and you got to move it over there. Okay? So this immediately becomes the following. Let me just change the color here. Make it look nice. Okay, fine. This becomes x squared plus y squared minus 6x. Move that negative 8y over. This becomes positive 8y equals 56. Okay? So from here, what we're going to do is we're actually going to perform completing the square. What you need to do is rearrange or shuffle up the letters on the left-hand side of the equal sign. So, for example, the x's go with the x's, the y's go with the y's. So we get x squared minus 6x plus something plus y squared plus 8y plus something equals 56 plus something plus something. Now, wait a minute. You're like, Trevor, where did you get these blank space from? I don't know what you're talking about. Well, this is what we got to do. What I just did is I just rearranged the x's together and the y's together. Your goal is to acquire a perfect square trinomial to express it in center radius form. In order to acquire a perfect square trinomial, you need to add a constant term to both of the groupings. And in order to get this, and you should have learned this again in Algebra 1, to get this, you have to use the classic formula, which is b divided by 2 squared, which that means take half the middle and square it. So take a look at this one. The middle term is negative 6. Take negative 6 divided by 2, which is negative 3. Negative 3 squared is 9. Put the 9 over here, put the 9 over here. What do you do to one side of the equation? You must do to the other side of the equation. This is all Algebra 1. So take this one. The middle term is 8. 8 divided by 2 is 4. 4 squared is 16. 16, 16. Boom. Now, this is where most people honestly get stuck. Right here. They don't know what to do from here. Some people get up to this point, they're like, all right, now what do I do? Well, that's perfectly normal if you are having trouble. The next thing to do is to factor. Remember, you need to factor to get your center radius form. What do I mean by that? Well, you need to take this and factor by the AM method. Take this, factor by the AM method. Remember what AM means. What adds to the middle number multiplies to give you the constant number. So, what adds to negative 6 but multiplies to give you positive 9? Well, that's just going to be x minus 3, x minus 3. Pretty simple so far? Then, in this case, what adds to 8 and multiplies to give you 16? Well, we're just getting y plus 4, y plus 4, because 4 times 4 gives you 16, 4 plus 4 gives you 8, and over here, negative 3 times negative 3 gives you positive 9, negative 3 plus negative 3 gives you negative 6. And if you haven't realized by now, completing the square, you get the same factor twice. And if you don't, you know you did it wrong. Okay? And when you add this on this side, this will give you 57, this will give you 81. Okay? So now what I'm going to do is I'm going to group these into a condensed piece. I could rewrite this as x minus 3 quantity squared. I could write that with just a square, that 2 representing that you could write this twice. Plus y plus 4 quantity squared equals 81. Doesn't this look a lot like the top equation that I wrote before, the center radius form of a circle? That was your goal. So now what we got to do is, we're not just leaving it there. It says determine and state the coordinates of the center and the length of the radius. We're almost there. The center of the circle is you're taking the opposite values of what you see here. The negative 3 and the positive 4. The center is positive 3, negative 4, and your radius is the square root of 81, which is the number 9. Ladies and gentlemen, that is your answer. The center is 3, negative 4, and your radius is 9. And that is how you do that question. Not too bad of a question. It was just a part